welcome to this tutorial in Cartesian coordinates. Now we've already used a couple of different types of Cartesian coordinates. In the first exercise we drew the square with an at 4, 4 value. That type of coordinate is incremental. In the second exercise we positioned the first circle 4, 4 from the 0, 0 point on the drawing. That one's absolute. And the third type is polar, where you can draw a line of a desired length at a precise angle. Now the word Cartesian comes from the French philosopher and mathematician René Descartes. Now you also probably know that cartography is the study of maps. And if you think about it, maps are all about locations. So we're looking at more of an analytical geometry that is a position within 3D space. Now we have three main types, as I said, and the absolute always uses this little icon here, wherever it might be on the drawing or wherever it is on the location. That point there right in the middle of the little X and Y sprig is the 0, 0 point in 2D geometry. Now anything along this line to the right or to the left is the x-axis. Anything directly up following this sprig, as you see by the notation, is the y-axis. Now that goes in both directions. If you go in the direction of the arrow, or you're traveling in this case to the right, that is a positive x move. If you're going against the direction of the arrow, that is a negative directional move. Same on the y. In with the arrow, positive numbers. Against the arrow, negative numbers. So let's look at it in action. If I zoom out a little bit from here, I've got a small sample. Get that one out. And then I'm going to just move that a little bit more central. And I'll explain. Okay, absolute coordinates. Everything is taken from a fixed location. Imagine you're a little guy standing in the middle of a field and you want to measure to the corner of the field. You're standing in one position, you want to know this location. Okay? You're standing in the same position, you want to know this location, followed by this one and that one. So it's very much a Cartesian coordinate system for a fixed point. But let me explain it a little bit further. If you're standing in the middle of the field and you want to find something in this corner, you can see by the numbers up there, this is the start point. If we enter 3 across in the X and 3 up in the Y, we will get a start point up here. Let me show you with a slightly different colored line. So I've got my polyline. The Cartesian 0, 0 is always going to be here because that is the fixed location. So if I enter 3, 3, like it says on the diagram, I'm going to start my line from that dead corner. Now to get down to here, even though this is 6 inches in length, I'm not going to enter a 6 anywhere in the equation because we're not measuring from this point here. If we were, that would be incremental and it would require an at sign. We're measuring always from this fixed location. Okay, so from this fixed location here, it's 3, minus 3 because we're going against the y. Okay, so 3, minus 3 would trace our line directly down to the corner. Now if we're going to be moving in a backward direction, you know there's going to be a minus of some kind, but again it's not minus 6 because we're not measuring from this point, we're always measuring from this point here. So that would be x is always first, minus 3 minus 3. And if we enter that one in, minus 3, comma, minus 3, enter, you'll see that it will trace to that point there. Okay, the last two. Minus 3, 3. So from here, it's minus 3 in the x and 3 positive in the y. So minus 3, comma 3, enter. And then we can just enter the same number we started with because that position hasn't moved. It is a fixed location from this point. So we can just enter 3, 3 and get back to the start. An alternative method of closing any line, if it's completely closed or you want it closed, is C and then enter. That stands for close. Okay? So that is the absolute coordinate system. They're always affixed around a fixed location, and in the case of a drawing sheet, it's the center of the X and Y. Okay, so let's have a look at incremental. Move this one down. Incremental coordinates. So with incremental coordinates, we can pick a location to start. We're not dependent on being relative to the X and Y, which is the world coordinate system on the AutoCAD. So I'm going to grab myself a polyline again, and I'm going to come down and I'm going to pick that as a start point. Now everything at this point is relative to these positions. Okay, so we're now relative from this point. So to make it so that we pick it from this point and not down in the corner where the Cartesian little sprigs are, the X and the Y, we need to put an @ sign in front to signify that we're measuring from this point and not from the absolute 0, 0. So we basically say @ and then if we don't want to move in this direction, which if it's a straight vertical move we don't, we just want to go up in the Y, we have to annotate the fact that we don't want it to move. So we have to do @0, so we don't want to move in the X at all, and we want to do a 5-inch move upwards. Enter. Now from this point now, because we're going to put the @ sign in again, and that means incremental from that point, we're going to be moving 4 inches across in the X, but not up or not down. So we just want that again as a horizontal line. So that will be @4, 0 to that point. The next move is our first minus move, and it's minus only in the Y. Okay, so you probably guessed it, it's going to be @0 in the X, -1 in the Y. Our next movement is going to be across in the X, because we're traveling along the line of the X sprig, so it's going to be a positive 3.5. So that would be @3.5, 0, and then enter. Now coming down, this is a negative movement in the Y direction from that point. So that will be @0, so that's 0 in the X, -3 in the Y. Now we're going to reverse what we did from up there. So it's going to be -3.5, 0, followed by @0 in the X, -1 in the Y. And of course, we just have to enter a C for close. Okay, and that was done. The last type of coordinate system, and let me just grab my pan hand there, is the polar coordinate system. Now, if you can imagine that this is normally done getting out at a set length at a precise angle, you can see I have a box drawn here. if I use the corner of the box, and remember from what was stated in the drawing video on the drawing commands, all angular lines are done with a 3 o'clock, that's this position there, as a 0. Now any rotational or polar movement around this point in this direction, which is counterclockwise, would be a positive number. So hence the 45 is a positive number. If I was going to take a line from here and go downwards by 45, I would do a negative number. So it would be negative 45. So just going to grab a polyline, come from this point here, and then enter at the length, which is 3, then shift and the comma key, which will give you the open angle, and then 45 and enter. And that gives us a line precisely 3 inches long at an angle of 45 degrees. Okay, so those are the 3 different types of coordinates as we use them in AutoCAD. And we'll be going over a slightly different one later as well. But basically, that's it. Practice it, have fun, and I'll see you in the third exercise.